Hey guys, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are dealing with question 5 from the grade 12 mathematics June 2022 paper 1, right? That was written in the Gauteng province, right? We are using this paper as a way to revise the work that we've done in term 1 and term 2. All the work that we've done in term 1 and term 2, we're using this paper to just help us revise to see whether we understand things that we're supposed to understand or not, right? And in this video tutorial, guys, like I said, we're dealing with question 5, and question 5 is also still dealing with functions, right? We're still dealing with functions. We are dealing with a quadratic function in this question, and we're also dealing with an exponential function, right? So if you want to watch a video that gives you guys like a tutorial on everything that you need to know when it comes to a quadratic function, please make sure that you watch this video tutorial, guys. Please make sure that you watch this whole video tutorial, guys. Please make sure that you do not skim through the video tutorial, guys, because you're trying to understand what's going on. So if you're skimming through, you're just writing the solutions, but you're not getting the explanation, right? Please make sure that you watch the whole video tutorial to listen to the explanation and as to how you're supposed to approach, because that will really help you guys in your tests and in your exams, all right? Before we get started with the video tutorial, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a new video tutorial. All right, guys, so without any further ado, let's get started with today's video tutorial. Question 5. The graphs of f of x, which is equal to 2 open bracket x plus 1 all squared minus 8, and g of x, which is equal to a half all raised to the power of x, are represented in the sketch below. P and Q are the x-intercepts of f, and R is the turning point of f. A, with the coordinates of -2 and 4, is a point on the graph of G. Okay, so I'm just going to quickly highlight the graph of G in red, and I'm going to highlight the graph of F in green so that we do not become confused. All right, and then we are told that the points P and Q, right, are the x-intercepts of our f of x function, and we are told that R is in fact a turning point of our f function, and we are also told that the point A there has the coordinates of -2 and 4. All right, so we're going to start off by answering these questions, guys, right? So please make sure that you're paying attention and you're also taking down notes. Okay, we're going to start off with question 5.1. It says write down the equation of the axes of symmetry of f, right? So they want the equation of the axes of symmetry, guys. What do we know when we actually have to write down the equation of the axes of symmetry for a quadratic function? Guys, you need to remember when you're dealing with a quadratic function, okay, to get the axes of symmetry, you use the equation x, which is equal to minus b over 2a. Always remember this, right? But what are we noticing about this particular function, right? We are noticing that this quadratic function is actually given in the form of f of x, which is equal to a open bracket x plus p all squared plus q, right? And then what do we know, guys? If your quadratic function is given in this form, to get the turning point, we literally just use the equation that is given to us to get the turning point, right? The x plus p expression will give us the value of the x coordinates of our turning point, and the q value will give us the y coordinates of our turning point. And what do we know about the x value of our turning point, right? the turning point of your parabola is the point where your parabola is basically divided into two equal halves, right? So your line of symmetry for your parabola goes through your turning point, right? So because we already have what the x coordinate is for your parabola, we don't even have to basically bother by writing that x, which is equal to minus b over 2a, right? Because we already know that for this parabola, okay, this parabola is given in the form of, okay, so what would be the turning point of this parabola or the quadratic function, right? You simply x coordinates. So you're going to say x plus 1 and you're going to equate it to 0. Therefore, x is equal to -1. So the x coordinates is -1. And what is the y coordinates of your turning point? It is that -8. All right. So we basically have the turning point for our parabola, right? That turning point there is -1 and -8, right? And we know that the point where your parabola turns, right? The turning point of your parabola, right? That is where your line of symmetry, that is where we draw our line of symmetry, because that is where your parabola is basically divided into two equal halves, right? Therefore, for this equation, the equation of the axis of symmetry of f is just going to simply be x, which is equal to -1, because they want the equation, right? So for something to be an equation, it needs to be something is equal to something. All right. Okay. But guys, if you don't see that point there and you want to really just take the long route, you can just simply do this. Okay. You're just going to expand the inner bracket, multiply the 2 in, add your like terms. What is your equation that you're supposed to use to get your axis of symmetry? We know that we're supposed to use this equation, x, which is equal to -b over 2a. So what is our b? What is our a? Okay, that is our a. That is our b. Substitute the value of b and your a into your axis of symmetry equation. All right. Please note, guys, you don't want to take the long route when it comes to this, because it's really just out of 1 mark. All right, next question. Write down the coordinates of R, the turning point of F. So the nice part here is I've already gone into the details of basically how you get the turning point, right? I did mention that to get the x coordinates, right, you focus on that inner expression, the x plus p expression, right? And you equate it to 0 and you solve for x. And then to get the y coordinates, you look at the value of your q, and in this case it's -8. So the turning point for our point R in this case is -1 and -8. Next question. Determine the coordinates of P and Q. All right. So we have now, right? You need to determine the coordinates of our P and Q. So what is our P and Q? P and Q are points that are on our f of x function, right? So what do we see that? We see that, and we're even told that P and Q are the x-intercepts of our function f, right? And then what should we do then to get these x-intercepts, right? So guys, to get the x-intercepts for this function, we are given the equation f of x, which is equal to 2x plus 1 all squared minus 8, right? What you need to do here, guys, is that you need to basically expand this expression, get rid of the brackets, right? And then get this equation to be in the form of f of x, which is equal to ax squared plus bx plus c, right? And once this equation is in this form, then we can basically find the coordinates of our x-intercepts by just obviously either using the quadratic formula or just by using the process of inspection, right? So let's just quickly get this quadratic function in the form of ax squared plus bx plus c. Okay, so guys, I did mention, right, to quickly now write out this bracket, you literally just square the first term, right? You square that x, okay? So it's going to be x squared, okay? And then you are going to multiply these two terms together and you're going to double them. So x times 1 is 1x, and if you double it, right, it's going to be plus 2x, right? Okay. And then the last thing that you're going to do is you're going to square the last term. Okay, so if you square the last term, it's going to be 1 squared is just 1 minus 8, right? And then, guys, we're just going to multiply the 2 in. Okay, so it's going to be equal to 2x squared plus 4x plus 2 minus 8, right? Then you just bring down that 8. And then here, guys, what do? We just add our like terms. So it's going to be 2x squared plus 4x plus 2 minus 8 is minus 6, right? So now what do we see? We see that this quadratic function is in the form of ax squared plus bx plus c, right? And then here, guys, we can just simply factorize this, right? So how do we factorize that, guys? You need to obviously equate it to 0. So it's going to be 2x squared plus 4x minus 6, which is equal to 0. Guys, here I'm seeing that we can just simply just take out a 2 because we do see that we've got a common factor of 2. So if we take out a 2, you're going to be left with x squared plus 2x minus 3, which is equal to 0. Just divide all through by that 2. You'll be left with x squared plus 2x minus 3, which is equal to 0, guys. And we can just simply factorize this using the process of inspection. Okay, so we're going to just open two brackets equal to 0. So it's going to be x and x, right? We look at that sign there, it's a negative. So that tells us that we're going to have a plus and a minus, right? And then we look for the factors of 3, right? That if I plus or minus them, they will give me a 2. And if I subtract them, multiply them together, they'll give me a negative 3. Okay, so what are the factors of 3, guys? The factors of 3 is just 1 and 3, right? So plus, let's see, plus 3 and minus 1 gives us a plus 3 minus 1 gives us a positive 2. And then plus 3 multiplied by negative 1 gives us a negative 3, right? So we have basically factorized that. So then what are the x-intercepts of this quadratic function? We have found that x is equal to negative 3 or x is equal to 1. So who is who in the zoo? What are the coordinates of your P and what are the coordinates of your Q? Okay, someone will just leave it like that. You are not done. What are the coordinates for P? What are the coordinates for Q, right? So let's see. We found that we've got an x value of negative 3. So surely that negative 3 is that P there, the x for the P, because it's like the one that's on our negative x-axis, and the y is 0, guys, because it's on the x-axis. And then what are the coordinates for our Q? Our Q is 1 and 0 because the Q is on our positive x-axis, right? So the P coordinate is negative 3 and 0, and the Q coordinate is 1 and 0. Next question. It's saying sketch the... Oh, am I jumping something here? Sorry. Next question. Question 5.4. Determine the equation of the inverse, right? So if you see that g negative 1 is the inverse, right, of g. Okay, so we're going to go back to our function. What is our g of x function? I'm just going to quickly rewrite it here. we were told that the g of x function is given as 1 over 2 all raised to the power x. Okay, so how do you get the inverse of g? Guys, you need to remember, if they want you to get the inverse function, where you have a y, you put an x, and where you have an x, you put a y, right? It is just simply swapping the coordinates of your x and your y values, right? So, but what do I mean by this, right? We do agree that g of x is the same as saying y is equal to 1 over 2 all raised to the power x. I just said, where you've got a y, you put an x, right? And where you've got an x, you put a y. So here we see we have a y there, so we're just going to put an x, right? And then where we've got an x there, we're just going to put a y. So it's going to be 1 over 2 to the power of y, right? But then we are not done. We know that if we have a function, right, the equation of a function is in the form of y is equal to something. That means that we need to isolate this y variable, right? So to isolate the y variable, right, we just need to solve for y. So how do we do this, guys? We use logarithms, right? So what do we do, right? Remember, guys, you bring down this y, okay? You bring down the y, okay? So it's going to be equal to y is equal to, it's going to be log. I always say this x is already big on this side, right? So it needs to remain as big on that side. So it's going to be log x. And then we move this half to that other side. And if it moves to the other side, it becomes the base. So it's going to be log of x base a half, right? And then we've basically found the equation of the inverse of g. So the inverse of our g of x function, right, is y, which is equal to log x, right? Log x base half, right? So that is the inverse of g in the form of y is equal to something. Okay, guys? Okay, so please make sure that you watch all my paper one videos, guys, because I really explain how you basically use or you change your change your bases, right? So that's basically how you do it. For me, I find it simply to just say, right, you bring the y down, right? Since the x is already big on this side, it remains big on that side as well. And if you move that a half to the left hand side, it becomes smaller. Therefore, that is why we have put it there. All right, guys. Hope I didn't lose anyone. All right. Question 5.5 is saying sketch the graph of G. In other words, your G inverse in your answer book clearly indicates the intercept with the axes and at least one other point. Guys, you need to remember, like I mentioned, an inverse function is just the same function as the original function. The only change that happens is that you have basically swapped your x and your y coordinates. What do I mean by this, right? Let us first get the x coordinates and the y coordinates of our g function, right? Remember, guys, our g function, our g of x function is given as, remember, so this is just a quick recap, guys, so I don't lose anyone, right? So our g of x function is given as 1 over 2 all raised to the power of x. Let us just quickly write down the x and the y, like maybe just 4x-intercepts, 4x coordinates and like 4y coordinates of this function. Okay, let's just quickly do that so that you guys see what's going on. Okay, let's just quickly do that, guys. Quickly. Let's move. Right, so this is the x and this is the y. Okay, let's see. Let's look at this g of x function quickly. Right, we are only given the coordinates of a, which is -2 and 4. Okay, so I'm also going to start this function like at -3, -2, -1, 0, 1, and 2, right? Guys, we know to get the y coordinates, you are just going to simply substitute, right? Okay, we've got g of x. We want -3, so it's going to be -3, which is equal to 1 over 2, all raised to the power -3, right? Same here to get the coordinates, your y coordinates, you're going to just substitute -2, but we already know with the -2, if your x is -2, we were told that your y is 4, right? Remember, guys, we were given the coordinates there. If your x is -2, your y is 4. So you don't have to stress about that one, right? Okay, so we're just going to quickly just substitute all these values, right? Punch them into your calculator and see, right, what are the y values that you're getting, and then you are going to put them on your table quickly. All right, so if you punch all these values into your calculator, okay, so if you punch these values into your calculator, these are the x as well as the y coordinates that you will basically get for your exponential function g of x, right? But then they're telling us to sketch the graph of the inverse of g of x, right? So how do we get the graph of the inverse of g of x, guys? So like really, to just make our lives easier, you are just going to, okay, we said that the graph of the inverse of your g of x is given by the equation log of 1 over 2, log x base 1 over 2, right? And I said that the coordinates for your x and your y values are literally going to be swapped around, right? Literally, guys, swapped around. So as long as you've got the coordinates of your g function, then you've got the coordinates of your g inverse. Okay, so now these are actually going to be, these y coordinates are now actually going to be our x coordinates for our g inverse function, right? That are now, these values here are now going to be our x coordinates, right? So I'm just going to put them in the place of our x here. So it's going to be 8, 4, 2, 1/2, 1 over 4, right? And then the x coordinates for your original function are now going to become the y coordinates for our inverse function. -3, -2, -1, 0, 1, and 2. Straightforward, guys. And then from here, we are able to basically sketch our function because we've got the x and the y coordinates for our inverse function, and we are more than ready to sketch it. Okay. So if your x, guys, I'm just going to start off with 4 because I can't go all the way down there. So I'll just start with the 4. So it's 1, 2, 3. Okay. So if your x is equal to 4, what is our y equal to? Ooh, I need to go down. All right. So if our x is equal to 4, your y is equal to -2. So if your x is 4, then your y is -2. It's somewhere there. If your x is 2, your y is -1, somewhere there, right? If your x is 1, your y is 0. It's there. If your x is 1, a half, so somewhere there, your y is 1. And if your x is a quarter, your y is 2. So we see that, oh, okay, we see that here, our x-axis is like basically an asymptote because we see that now this function is approaching the x-axis, but it's probably never going to touch there. All right, you'll see that the more you go, you'll see that you'll get like, it'll keep approaching, but it'll never touch it, right? So we see that, oh, okay, this is actually an asymptote, right? So guys, this is basically how this inverse function is going to look. It looks something like this. Okay, and this is our inverse function, right? So that is our g inverse of x. Okay, so we have basically drawn our inverse function, guys. We are happy, right? And that is how it basically looks. Basically easier, right, in this case, to just draw a table for your original g of x function, right? Get the x coordinates, get the y coordinates, right? We just know to get your x coordinates, you just obviously just write down any values of your x, and then to get the y coordinates, you punch those values, right, into your calculator, and then you'll be able to get your y values. And then, you know, an inverse function, you literally just swap your x and y coordinates. And that is basically what we did there. And then by doing that, we are able to basically get our inverse function without making any silly mistakes. So that is basically my tip to you guys, right? Please use it, okay, so that you avoid making unnecessary mistakes. But I am going to do videos for you guys where I explain logarithms. All right. Okay. And then, guys, they said clearly indicate the intercept with the axes and at least one other point on g of x. So we have that is our intercept, and that is when your x is 0 or your y is, when your x is 1, your y is 0. And then we can just indicate any other point on this function. So you can just take any other point that we've got here. I'll just use 2 and -1. When your y is 2, we said your y is -1. I'm just going to indicate that one there. And then we've got the 3 marks. We are done. We are moving on to our next question. This question is saying, for which values of x is the inverse function g of x greater than and equal to -2? These questions are those type of questions where most learners just skip them because they don't even know what that question means. Okay, so obviously this question, this question, right, is that question that most students skip. Please don't skip it. Try this question. If you haven't drawn your function, chances are you would have skipped it because you don't even understand what it's, obviously you won't be able to understand what it's asking you, because this question is basically asking you to go to your function or even your table and see where the values of our g of x will give us, where the x values of our g of x function will give us y values that are greater than and equal to -2. Okay, so let's look at our y values. You want y values that are greater than, okay? Because it's saying you want your g of x function, you want x values that will give y values that are greater than and equal to -2, right? So that is our -2 here, okay? That is our -2. And that x value here is 4, okay? Okay, so you want x values, right, that will give y values that are greater than and equal to -2. Okay, so greater than and equal to. So x values that start from 4, we see that 4 gives us a y value that is greater, it's actually equal to -2. When your x is equal to 4, your y is actually equal to -2, right? So x values that are, what happens? X values that are actually less than and equal to 4, but greater than 0. Okay, so for this function, what are the x values that we need to get from this function that will make this function greater than and equal to -2? What are the x values that we need to use to get y values that are greater than and equal to -2? We see that, okay, when your x is equal to 4, your y is actually equal to -2. So we see that definitely, right, when your x is less than and equal to 4. Let's see. When your x is actually equal to 5, what happens? When your g of x function is equal to 5, what happens? Let's see. Let's substitute 5 into an x value of 5 into this equation. Okay, you get -2.3219. Okay, so we don't want that. So it mustn't be an x value of 5, right? So we are definitely starting from the x values must be less than, right, and equal to 4. But we know that because here this function approaches 0, but it never ever touches, right? It never touches your y-axis. Therefore, it must be greater than, but not equal to 0, because it never touches your 0. Okay, so to answer this question, okay, for which values of x is the inverse function greater and equal to -2, the question is asking, what are the x values of this inverse function that will give us y values that are greater than and equal to -2? That is exactly what this question is saying. And we explained that x values that will give y values that are greater than and equal to -2 are x values that are less than and equal to 4, but greater than, but not equal to 0. Okay, so you need to obviously just look at your function, or you can even just look at the table. what are the x values here that will give us a value that is obviously greater than and equal to? We see that when your x is equal to 4, right? But then if you were to continue, you'll see that you actually never get to x is equal to 0 here. You will approach 0, right? You'll approach 0 in all your x coordinates, but you'll never get to 0. So you will have to say that x values that are obviously less than and equal, x values that are less than and equal to 4, but that are greater than, but not equal to 0. Because what happens when it's equal to 0? You are going to get an undefined. When your x is equal to 0 there, you are going to get an undefined value. So that is why we're saying x values that are just greater than 0, but not equal to 0. Okay, guys, I hope I explained that one for y'all. And the last question, x times f of x is less than 0. What are you supposed to do here? Guys, the first thing you're supposed to do here, we know that our f of x function, this is just a side note here. I'm just going to put it on the side note for the side, all right? We know that f of x is actually equal to, we were given here that f of x is equal to 2 open bracket x plus 1 all squared minus 8. Okay, so here we are literally gonna substitute this value of f of x and slot it in there, right? First thing, we're gonna say x dot multiplied by, what is our f of x? You're gonna put that f of x there, right? This thing, we put it in there. We slot it inside there, right? So, okay, that's what we're gonna do. So it's gonna be 2, where we see f of x, we wanna just slot that whole expression in there. Okay, so it's x plus 1 all squared minus 8, right? We are going to just simplify the inner brackets, guys. I showed you guys how we're supposed to simplify that inner brackets, right? Please, like, make sure that you're watching these whole video tutorials. I don't want to hear someone asking me, ma'am, how did you get that inner expression? Because I did it in question 5.3. Okay, so that inner expression is 2x squared plus 4x minus 6. And then what are we going to do? We're going to multiply that x inside. So it's going to be 2x to the power of 3 plus 4x squared minus 6x. Okay, and we want to find out where is this less than, right? So this question is want to find out where is this function less than 0. That is what we're trying to find out, right? So then from here, guys, what are we noticing? We see that we've got a common factor of, is it 2x? Yes, most definitely it is 2x. So we're going to take out that common factor there of 2x. When you take out 2x, you're going to be left with x squared plus 2x minus 3 is less than 0. From here, guys, remember, if you've watched my inequality videos, right, you know, when you're working with inequalities, the first thing, guys, you need to do is you need to get your critical values. After you found your critical values, you need to put your critical values on a number line, right? And then once you've put them on the number line, you need to determine where these where this function is positive or negative on your number line. Okay, you need to find out where the function is positive or negative on your number line. So that is exactly what we are going to be doing now. We are simply going to be finding our critical values. So what are our critical values, guys, right? What are our critical values, right? So the first thing here, the first critical value, if you solve here, x is equal to 0. We are finding our critical values. X is equal to 0. Then here, guys, what do? You can just simply factorize that expression by using the process of inspection, right? So it's going to be x. I think we also did this. We had x squared plus 2x minus 3, right? So you already know in question 5.3, question 5.3, right? So you already know, you should know how to factorize this, guys, right? So you put an x and an x there. You look at that negative tells you what signs you're supposed to put there. So if it's a negative, it's a plus and a minus, because you want, when you're multiplying to get a negative, what are the factors of 3 that if I plus or minus them will give me a positive 2. So we said that it's positive 3 plus 3 minus 1 gives us positive 2. And then what are those factors that if you multiply together will give us a negative 3? plus 3 multiplied by -1 is equal to -3. So the critical values is x is equal to 0, x which is equal to -3, and x which is equal to +1. The next step, guys, we need to put these critical values on the number line, right? So we've got x which is equal to 0, x which is equal to -3, and x which is equal to 1. We literally put them on the number line. We are not stressing our lives, right? Put them on the number line, okay? We've got -3, we've got -3, we've got 0, and we have 1, right? So now what happens, guys? You need to look for values between these critical values, right? So you're going to obviously choose any value between these critical values, right? So I'm going to choose here, I'm going to choose a -5. I'm going to substitute that -5. Any value between -3 and 0, I'm going to choose a -1. And any value between 0 and 1, I'm going to choose 0.5, as well as any value between 1 and infinity, positive infinity, I'm going to use 2. And we are going to substitute these values into your equation, okay? So which equation am I talking about, right? Okay, which equation am I talking about? We are going to substitute these values into this equation and see whether we are going to get a positive or a negative. And that tells us whether this function is positive or negative then. All right. So I'm just going to rewrite that equation that we're going to be substituting these values into. Okay. So it's going to be 2x squared is 2x minus 3. Okay, and we want to find out where is this function less than 0. Right? Okay, so then we're going to start off by substituting -5, guys. Right, so we're going to start off with -5. Start off with -5. Sorry, guys. Okay, so when you substitute -5, it's going to be 2 minus 5 all squared plus 2 minus 5 minus 3. So if you substitute -1, you do the same thing. If you substitute 0.5, you do the same thing. And lastly, if you substitute 2, you do the same thing. Right? So if you substitute -5, guys, what do you get? If you substitute -5, you'll find that you get a negative value. Okay? You get a negative 120. Okay, if you substitute -1, what do you get? You get a positive 8. If you substitute 0.5, what do you get? You get a negative 1.75. And if you substitute a positive 2, what do you get? You get a positive 20. So what does this tell us, guys? We are not going to be focusing on the values, right? But what are we going to be focusing on? We're going to be focusing on these signs here. Those signs are telling us where this function is positive or negative, right? Those signs actually tell us that between between negative infinity to -3, this function is actually negative, right? It's negative, okay? Between -3 to 0, where we substituted -1, this function is actually positive, okay? Between 0 to 1, where we substituted 0.5, this function is negative. And between 1 to infinity, where we substituted 2, this function is actually positive, right? So that is basically what we did. We want to find out where is this function negative, because the question is saying where is it less than 0, and where is it less than 0? It's there where it's negative, right? And that is your answer. This function is less than 0, right? When from negative infinity to -3 and from 0 to 1. Okay, so how do you write that in set builder notation or interval notation? So this is the final answer that you're supposed to write. So you can write it in set builder notation or interval notation, but if you want to do it in set builder notation, right? So where is this function less than 0? It's less than 0 when what is happening, guys? It's less than 0 here when your x is less than 1 but greater than 0, right? And where is this function less than? Also, we know that this function is less than 0 here. So when your x is actually less than -3, right? So your answer in set builder notation is when your x is less than -3 right? And x is between 0 and 1. Please note that we haven't included, this is an open circle, right? Because they just want to know, just want to find out where it is just less than 0, right? And that is where it's less than 0. Because if you were to include this, what happens at 0? It'll just be 0. It'll be equal to 0. But we don't want that. We want it to be less than 0 and not equal to 0. So in set builder notation, this is your answer. But if you prefer interval notation, okay, your answer is from open bracket negative infinity to negative 3 in union with 0 and 1. All right, guys, I love these last few questions, right? Just a quick recap when it comes to question 5.6.2, because this one tends to give most learners a hard time. This question wants to find out where this function is less than 0, right? So the first thing that you need to get, guys, is that you obviously need to get your critical values. Number 2, after you've got your critical values, make sure that you draw a number line and put your critical values on the number line. And number 3, from the number line, what we did is we just took any value between negative 3 to negative infinity, right? And any value between negative 3 and 0, and any value between 0 and 1, and any value between 1 to positive infinity, and we substituted those values into this equation. It can even be this equation, guys. It really doesn't matter, right? It can be that equation, right? The initial equation. Obviously, it has to be the equation where you've substituted the value of your f of x. And by substituting those values into that equation, we are able to basically find out where the function is negative, right? So by substituting negative 5, we found that it's negative there. By substituting negative 1, guys, it can be any value between negative 3 and 0. It can also be negative 2. It can be negative 0.99. It doesn't matter, okay? It can be any value between this interval, okay? By substituting that, we found that the function is positive in this interval, and then we found that the function is negative in this interval, right? And we found that the function is positive in this interval, right? And then from there, guys, we were able to basically answer our question, because we were able to see that, oh yeah, this function is actually negative here, and this function is only negative within that interval. And then you can basically choose how you want to answer your answer, depending on what you're comfortable with. If you're comfortable with answering in set builder notation, you can answer in set builder notation, right? And if you're comfortable in answering interval notation, you can answer it in interval notation, unless they specify and say answer it in set builder notation or interval notation, right? But if they don't specify, guys, you can answer it in either set builder or in interval, right? Okay, and then, guys, that is basically going to be your final answer. Okay, so guys, we are basically done with question 5, right? I hope that I basically explained everything nicely and detailed for you guys. All right, please also make sure that you comment on the comment section and tell me how you guys found this video tutorial. Guys, please engage with me. That will really mean the world to me. In the next video tutorial, we are going to obviously have to start with question 6. And question 6, guys, it deals with financial mathematics. But before I upload this video tutorial, I obviously want to come up, I obviously want to upload my own video tutorial where I have basically explained financial mathematics to you guys, so that you've got a point of reference if you get stuck. Right, I don't want to just upload a past paper for the sake of uploading a past paper. The past paper is being uploaded so that you guys practice. We are not cramming, because cramming is not going to get you anywhere. Okay, so yeah, guys, so I'm gonna obviously try and just make sure I upload the financial mathematics video summary before I upload this video tutorial. Guys, please make sure that you are subscribed to the channel, and also please make sure that you give this video tutorial a huge thumbs up, because that will really help the channel grow, and it will help the channel reach more learners that want to better their mathematics marks. And that is it, guys, and I'll see you guys on my next video tutorial. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.